Since 2015, a single star has done something no other star in the entire Kepler dataset has ever done, dimmed so dramatically, so irregularly, that for a brief period, one of the seriously considered scientific explanations on the table was an alien megastructure. The star is officially named KIC 846252, but almost everyone calls it Tabby's star, named after astronomer Tabitha Boyajian, who led the team that first flagged its bizarre behavior. It sits roughly 1,470 light-years away in the constellation Cygnus, and at first glance it looks completely ordinary, a star somewhat hotter and brighter than our sun. What isn't ordinary is what happens to its light. When a planet passes in front of a star, it blocks a small, clean, predictable amount of light, typically less than 1%, dipping and recovering with perfect regularity orbit after orbit. Tabby's star broke that pattern completely. In 2015, citizen scientists sifting through NASA's Kepler data as part of the Planet Hunters project flagged something nobody could explain: dimming events, dropping the star's brightness by as much as 22% at irregular intervals with irregular shapes, nothing like the clean signature of an orbiting planet. No known planet could cause a dip that deep. That single fact eliminated the simplest explanation almost immediately and left astronomers searching for something else entirely. In 2015, physicist Jason Wright and colleagues published a paper doing something astronomers rarely do publicly, seriously proposing that an artificial structure, a Dyson swarm built by an advanced civilization to harvest the star's energy, was a hypothesis worth investigating, precisely because nothing conventional seemed to fit the data. The SETI Institute took the possibility seriously enough to point radio telescopes directly at the system, searching for any signal that might confirm something intelligent was actually out there. More than 1,700 people even funded a Kickstarter campaign, raising over $100,000 just to secure dedicated telescope time to keep watching. The alien hypothesis didn't survive close scrutiny for long. In 2010 and 2018, Boyajian and Wright's team caught several dimming events happening in real time and made a crucial discovery. The star dimmed by different amounts at different wavelengths of light. A solid opaque structure, whether a megastructure or a planet, would block every wavelength equally. Dust wouldn't. That single result effectively ruled out the megastructure hypothesis and pointed towards something far less exotic but almost as puzzling: an uneven, irregular cloud of dust orbiting the star roughly every 700 days. Except knowing it was probably dust didn't actually solve the mystery. It just moved the question. What kept producing that dust? Why did it move in such an irregular, asymmetric pattern? And what explained the separate, much slower, long-term dimming trend? A puzzling 20% drop in brightness recorded across historical photographic plates spanning 1890 to 1989, entirely apart from the short, dramatic dips? For nearly a decade, those deeper questions remained genuinely unanswered. Then, on July 6, 2026, a new possibility finally arrived. A team led by Cristina Madurga Favieres at the University of Warwick, publishing in the monthly notices of the Royal Astronomical Society, identified something new hiding in NASA's TESS data, a rare, unusually symmetric transit signal suggesting a giant planet roughly 9.5 times the mass of Jupiter orbiting the star on an approximately 3-year path. It's the first solid planetary candidate ever found in this system, and it may finally help explain part of the dust generation process that's puzzled astronomers for a decade. To be properly honest, this doesn't close the case entirely. The newly proposed planet is a strong, well-supported candidate, not a fully confirmed, complete explanation for every strange dimming event this star has ever produced. Astronomers are already planning to use the James Webb Space Telescope during the planet's next predicted transit, expected in late 2026 or early 2027, hoping infrared observations might finally characterize whatever surrounds it directly. What makes Tabby's star such a striking case study isn't really the alien hypothesis, however famous it became. It's the reminder that mainstream science was genuinely willing to seriously investigate an extraordinary idea when nothing ordinary fit the evidence, patiently ruled it out using better data, and kept searching for over a decade until a far more grounded answer finally started to emerge. What do you think? Now that a real planetary candidate has finally been found, do you think it fully explains a decade of strange dimming, or is there still something we're missing? Let me know in the comments. Subscribe, because next time we are covering 3I Atlas, an object from outside our solar system that is passing through our cosmic neighborhood right now.